We're going to go ahead and make a homemade trig table now. It says in order to get results that are reasonably accurate, you should make all of your side lengths at least 5 centimeters long. That's just to make it so it's easier to measure since they're going to be longer. And then it asks you to measure each length to the nearest millimeter, so as accurate as you possibly can. It tells you your teacher will assign you 2 angles to investigate, but I actually want you to do as many of these as you possibly can. And then it asks you to do 3 things. So first thing, you're going to draw a right triangle. I circled right so you remember that every single triangle you make will have a 90-degree angle. And then you're going to also use the assigned angle on the table. Then you're going to measure the lengths of each of the 3 sides. You'll write those down. And we'll actually compute the ratios of the sine, cosine, and tangent of the assigned angle. So let's go ahead and move on over to our graph on the other paper here. I'm going to start in the center. It doesn't really matter where you put it, but I'm just going to draw it over here somewhere. So you'll start with just drawing a segment of whatever length that you choose. So I'm just going to draw that long. All right, so this looks like, if I measure it with my ruler, just to be more accurate, it looks like it's 8.6 centimeters. I'll say this is 8.6 centimeters. So on this table, I'm going to just choose to do this 10-degree one, but remember, it doesn't just give you 10 degrees. All of these are going to be right triangles. So I also have a 90-degree angle in addition to my 10-degree angle. This is where our protractor comes into play. From one of the corners, doesn't matter which one, I'm going to put a big dot there. I'm going to place my protractor so that the dot is lined up here, and then this line that I drew needs to match up with the line that's on my protractor. That looks pretty good. And now I'm going to look for 10 degrees. 10 degrees is an acute angle, even though there's a 10 degree out here on the left. If I drew this, it would make an obtuse angle. So I'm going to actually use the 10 degree on the right hand side here. So it's the one right over here, which is that one there. That's about 10 degrees. So I just made a little dot, and then I'm going to connect these 2 dots to make my 10-degree angle. Again, this one, it doesn't matter how long you make it. Oh, sorry. I didn't actually draw a nice segment there. But if I connect it like that, this will be my 10-degree angle. So the rest of it, I have to make sure it's still a right triangle. So I'm going to keep my 8.6 that I chose arbitrarily before, put a dot at this corner, and do the same thing, but now I'm going to measure a 90-degree angle to make sure that it's actually a right triangle. So put the dot here, line up the segment with this line on my protractor, and I'm going to look for 90. So here's 90 degrees. Put a little tick mark there, and then I'm going to connect. Notice when I connect it, I know it doesn't look like a triangle right now, but if you're looking at the fact that, you know, I've made this 90 degrees, I'll just put a box here, I made this 10 degrees, so this is kind of where they force to be intersecting here. So this is actually where my triangle is, this one over here on the bottom. These are all like random extensions that I didn't end up using. So I'm going to take my ruler and I'm going to measure each of the sides. So this looks like it's 1.8 centimeters. So again, the more accurate you can be with the side lengths, I think the easier it will be for you later. This looks like 8.7 centimeters. It's kind of good because my hypotenuse needs to be longer than the other 2 sides, and it is.